Our final section of chapter 3 is section 6, which is talking about perpendicular lines and the distance, particularly going from the distance from one point to a line. So we want to be able to locate the shortest distance. We're going to be doing this lesson in class, so this isn't a video that needs to be watched ahead of time, but in case you did miss class, it's available for you to watch. So we want to be able to really find the distance, the shortest distance from a point to a line. And when you think about that here, I have a line with a point, and I have 3 dotted lines to that. If I were to measure each of these lines here, one of them is going to be shorter than the other. And hopefully you can kind of visually look at this and see that the longest line is going to be this blue one here. That's going to be our longest line. Second longest, the green one. Purple's going to be the shortest one. And they get shorter and shorter and shorter until I were to make one that is making a perfect 90-degree angle with the other line. And that's going to be our shortest distance. So when you're talking about the distance between a line and a point, not on a point that's not on that line, the perpendicular distance is always going to be the shortest distance. So when you're trying to get something, go places, and you want to get there the fastest you can and the quickest you can, you want to try and go perpendicular to it. That might mean you have to walk through someone's yard or someone's house to get there if you had to get there the quickest or the fastest. So we're talking about perpendiculars and their distance, and what we want to be getting with this, and it's going to be coming up later, is talking about this word called equidistant. And when we talk about equidistant, hopefully you see there's 2 words kind of mushed in here. Hopefully you see the word equal and distance. And so when we're talking about equal, we're talking about same. So we're talking about 2 lines that are going to be having the same distance. Now we've been spending all this time working with parallel lines, and parallel lines are always equidistant because the points along them are always going to be the same. The distance from all of these points will always be the same, the perpendicular distance. So how do we do this? We're going to kind of work at some basic ones. I mean, you can get more advanced with this, and there's easier ways that you can find this down the road, but we're just going to go ahead and look at a couple basic problems here, trying to find the distance from a point to a line. So line AB here that I have, so here's A and here's B. There's its coordinates. It says find the distance between line AB and point P, which is at the coordinates of 2, 4. So if I wanted to figure out what the distance was, I want to figure out how far is this going to be. Well, when I'm trying to figure out the distance, we're going to be using the distance formula. Well, the distance formula of P to this line, I need to know 2 endpoints. I know the coordinates of P, which is 2, 4, but I do not know the coordinates of where the perpendicular line meets line AB. So we are going to use our slope formula and what we know about perpendicular lines to come up with that point. So what we need to first of all do is we need to find the slope of line AB. So I'm going to do that, -6, subtract 3, and divide that by 4, subtract a -5. So here I get -9 divided by, looks like +9, so my slope is -1. So the slope of line AB is -1. Well, if I'm going to have a line that's perpendicular to that, the perpendicular slope of AB is going to be then +1. So it's the opposite reciprocal. Here I've got 1/1 negative. It's going to be +1/1. So now from point P, if I go up 1/1, I'm kind of going in the wrong direction. So I want to go down 1 to the left 1, down 1 to the left. And I'm going to keep doing this until I see where I am now crossing my line of AB. And it's meeting at the coordinate of -2, 0. And at this point here, this is going to allow me to figure out what the distance is from point P to line AB. because this is going to be perpendicular here. So now we can use our distance formula, which is going to take 4 and subtract 0, take that value squared, plus 2, subtract a negative 2, take that answer squared. So I'm going to take 4 squared plus another 4 squared. And so 16 plus 16 gives me square root of 32, which square root of 32, that's the exact measure. And if I wanted to find the approximate measure of that, we would have 5.66. And there's our approximate distance from point P to line AB. So you had to find the slope, then we had to find the perpendicular slope, and then we're using our distance formula. I'll go through one more example if you need it. So here I once again have A and B, and then I have point P, which is all by its lonesome. And I want to find out what the distance is from point P to line AB. So I need to figure out what the perpendicular distance is. So I need to find the slope of AB first. So here I have -6, subtract 2, divide that by -1 minus a -5. So that gives me -8 divided by +4. So that gives me -2. So my slope of AB is -2. That means my perpendicular slope is going to be +1/2. So I'm going to go down 1 over to the left 2, down 1 over to the left 2, because if I go down and to the left, it's staying negative there. And notice that it is meeting, or it's going right on to line AB, and it's meeting at the point of 1, 2, 3, -3 and -2. And there's its point. So now I can find the distance from P to this point here. I'll just name it X. And by using the distance formula. So the square root, I'm going to take 2 and subtract a -2. Take that squared plus 5 minus a -3 squared. So I end up with 4 squared plus 8 squared. So I have 16 plus 64. And I end up with the square root of 80. So the distance from point P to point X that I have there is the square root of 80, which the approximate measure of that is 8.94. There you are. So if you weren't in class, or you were in class and you just needed to kind of watch this again, hopefully this helped. Write down any questions that you have.